Hello, welcome to this lecture video. I'm Teacher Melai, and let's talk about the static group pretest post-test design. So this is the figure that shows the static group pretest post-test design. So in our figure, so we have pretest. So both groups will be given pretest, then they will both be given treatment, and they will also be given post-test. So as that you can see in the figure, the space or the blank means that the intervention that will be given is the traditional or the existing method. So it is static because as mentioned in other previous videos, the group is intact or it is already an existing group without randomization. Okay, so let's go back to the same topic, effect of blended learning in the performance of the students in mathematics. So obviously, we always have the question, what is the performance of the students in mathematics? Because we have the before and after the pretest, before and the post-test. So we will consider the performance before and after the intervention. So in presenting this, so you can actually come up with one table presenting the performance of the students before and after using the blended learning and using the traditional method. And then for number two, is there a significant difference between the gain score of the students in mathematics when grouped by given intervention? So we have here, instead of placing the word performance, I make use of the word the gain score simply because we are controlling the effect of the pre-test, which means that if I will consider only the post-test, it might be that the student is already the student already got high score in pre-test, or the student got a lower score in pre-test than the score in the post-test. So instead of considering the difference between the pre-test and the difference in between the post-test, what we need to consider here is the gain score. Or if not, you can also ask the question, is there a significant difference between the post-test scores of the students in mathematics when grouped by by their interventions after controlling the pretest? You can also make or you can also use pretest as a covariate. Okay, so let us now consider the dummy data for us to test our, or rather to answer our question. So in our table or our data set, so we have the pre-test and the post-test. So as the what we used in our previous video, we also have the percent score. So percent score is the pre-test percent score. And for post-test, it is the percent score also in the post-test. Actually, this is, as again mentioned in all other videos, this is your option because just in case that you prefer to use the actual scores because the interpretation now of the performance depends on the actual scores, then you can use the actual scores. Okay, so what we need to do is to identify what appropriate tests can we do for us to come up now with answer in the question, is there a significant difference in the gain score? First, we need to define what is the gain score. So the gain score is actually defined as the difference between the post-test and the pre-test. So, of course, if you obtain a positive, which means that there is really a gain, or if the result is negative or zero, it means that the score in pre-test, if it is zero, the score in pre-test is the same with the score in the post-test. Or if it is negative, so the score in the post-test is lower than the score in the pre-test. So how to compute for the gain? So let us compute here the gain score. So in this video, we're going to consider the actual data. So for the actual data, again, we will subtract the post-test and the pre-test. So how to do that? So let's make our data or our Microsoft Excel clear. So let's zoom it. So equal sign. Let's use the actual data. Post-test less our pre-test. And then drag it until to the last. Okay, so this is now, so some of them obtained a negative score. So it means that the scores in the post-test is lower than the pre-test. Okay, next. So we have here now our gain score. So how will we know what appropriate test to use? First, our objective is comparison. So let us write that. So our objective is comparison. And what will we compare? Two groups. The treatment and the control group, or group 1 and group 2. Next, what is the nature of the data? So scores is interval. So it means that it is numerical. Next, is the data normally distributed? Again, since we are using the same data, or rather 60 sample size, 34 each of the group, then by central limit theorem, so I'll just place CLT. So our data is sufficiently large and equivalent. So which means that by CLT, it approaches to normal, which means our data is normally distributed. So since our data is at least interval and our data is normal, then we can use a parametric test to test now or to answer the question on significant difference. And the test for comparison for parametric test is, again, t-test 4, because it's a comparison between independent group. So group A, or the treatment group, is independent group from group 2, which the group who received the traditional intervention. So again, just to reiterate, so we are going to use t-test for independent samples. Okay, so let us do that. So let's go back to our data. So what will we do? We will use the data analysis. So insert, where's the data? So data analysis, and locate the t-test for. Okay, so we again, of course, need to check if we're going to use t-test to sample assuming equal variance or to sample assuming unequal variance. So we missed that part. So we have to open again a calculator for homogeneity. So as mentioned, you can actually just click online statistics calculator and you can find www.sox-statistics. That's the one we are using. Then you have to click that. And let's again locate where is that Levin's test of homogeneity of variance calculator. So for sample 1, so we are going to enter the gain score for sample 1, and for sample 2, the gain score for sample 2. So this is from 1 to 30 or 1 to respondent 30. So it's aligned with respondent 30. So let's copy this and paste it. Next, so let's go back to our data and also copy 32 to 61 or respondent 31 to 60. And go back, paste, and click calculate. Okay, so let's go down. So the requirement of homogeneity is met. So which means we will go back to our data and use the equal variance assumed. So let's do the procedure again. So data analysis, and we are now confident that we're going to use t-test to sample assuming equal variances. Then click OK. Okay, so variable 1 is the gain score for group 1. So this is until 30. Respondent number 30. So be careful in, of course, also selecting for your data. So it's from cell 2 to 31. And then for 31, so select until, of course, to the last, it's 32 to 61. So we did not place the labels, or rather we did not select the labels, so there's no need to click for that. Then just click OK. So this is now the result. So what is our table, or the result is telling us? So we have higher gain score for group 1. So this is the treatment. And group 2 is our control. So there is a gain of average of 12.7 for treatment and 0.9 for control with the following variances. But as mentioned, we're going to show the value of SD instead of the variance. So this is equal SQRT, open parenthesis, and close, and drag it for control. So with a standard deviation of 4.24 and 4.38 respectively. So let's also scroll down for the result. So the T is statistics. So assuming that we use the one-tailed, so it means that the T is statistics is 10.59 and the probability value is 1.73996 E negative 15, which means that this is times 10 raised to negative 15. Converting it into whole number, this will be, or rather converting it into non-scientific notation, it is 0.15, the 0 before 1/7. So it is almost 0. So which means P is less than 0.01. Again, the result means that it is significant. So what can we conclude now? So since the result is significant, therefore, the mean gain score of the group given blended learning is higher compared the group with the group given traditional or existing method. So since it is significantly higher, then we can say that the students performed better in um, performed better than those in the control group or in the traditional. So the effect is that it can improve since the result is positive, actually both of the treatment, because the result is both positive, it can actually gain or improve the scores of the students when given the intervention